What you're seeing here are a couple of silly functions. Keep odds and sum. They're simple functions. They're not really doing much at all. And they're silly because we never actually write these functions. But I've created them so that we can look at the different pieces and parts that are available to us when we are putting together Erlang functions. Both of these functions are in the examps module. All functions in Erlang exist in a module. We can use them outside of the module if we export them. If we don't export them, they cannot be used outside of the module. Both of these happen to be exported so that we can. So let's first take a look at the keep odds function. You can see it on lines 4 through 8. It consists of two clauses. In Erlang, we divide functions into clauses, each clause handling a different case where that function is going to be used. So if we look at the first clause, that would be the entirety of line 4. We know it's a clause because it ends in a semicolon, just like independent clauses end in semicolons in English and in many other languages. So the function has a name, keep odds. It has a parameter list in the parentheses. It has a single parameter, which is a list. And on line 4, you can see that if keep odds is handed an empty list, it gives an empty list back. If you have no numbers in your list, then there's no odd numbers to be the value of your function. If we look at the second clause of keep odds, this is a case where the list is not empty. I know that because I can see the H and the T with the up bar in between them. That is, as we learned last week, going to split the head from the tail of the list. So the first value is going to be H, and all of the rest of the values are going to be in T. And this is only going to happen when the absolute value of the head modulo 2 is equal to 1. So that's how we're checking to see if something is odd. That when clause is called a guard, and it guards the code that is the value of this clause, keeping out situations where it's inappropriate. So it's guarding that code. You can see on line 6, that's the last line of the clause. What happens there is that we are going to prepend the head, which will be odd in this case, to a list that is the value of the recursive call of keep odds, and we pass it the tail, so everything else that we haven't checked yet. Recursion is the way we do functions in Erlang. There are no loops. We don't need them. Recursion is a natural and normal way of getting things to happen over and over again. So we take the head of the list. Because it's odd, we're going to hang on to that, and we're going to be building our list by prepending each one of the odds to whatever list we get back. Now, eventually, that list we get back from keep odds will be empty because the tail will end up being empty, and the first clause will be executed. The third clause of keep odds is lines 7 and 8. This is the clause that will be active when we don't have an empty list, when we've got a list that has something in it, but the head is not odd. And so there we don't want to keep the head around in our result because it's not odd. So all we need to do is call keep odds recursively and pass it the tail. We're just going to abandon the head and not use it. And you can see on line 7 that the head, the H, has an underscore in front of it. That tells Erlang, hey, I'm going to take the head off the list, but I'm not actually going to use it. Please don't send me a complaint or reminder that I've got a variable here that I'm not using. You'll notice that the third clause, which ends on line 8, ends with a period. Again, this is following language conventions. When the idea is complete, we put a period there. So independent clauses in English sentences and in many others and in semicolons. And then when you get to the end of the idea, there's a period for the end of the sentence. You'll also probably be wondering, how does it know which one of these clauses to execute? Well, the way it does it is it uses pattern matching, and it matches top down. In other words, it'll first try to see if the parameters that are past the function match with the parameters needed for the first clause on line 4. Then it'll see if it matches the parameters for the second clause, which begins on line 5. And that includes the guard. And then it'll see if it matches the parameters in the last clause, our third clause, which is on line 7. We've covered all the possibilities, so it will find a match. If our code gets to the point where it doesn't find a match, then it will throw an exception. But if you're careful and you think your work through, then you will always have a match. Let's take a look at the second silly little function in here, the sum function. You'll notice it has 2 parameters. You can see that on line 10, its first clause. It has the first parameter that is a list, which in this clause happens to be empty, and something named accumulator. The value of this clause will be the accumulator. An accumulator is something that accumulates the value gradually over time. So it could be a list that we gradually prepend stuff to. It could be a number that we add stuff to or subtract stuff from or multiply, divide, whatever. It could be strings that we're sticking together to make a larger piece of text. Could be lots and lots of different things. In this case, for some, it's just going to be a number. And we're going to gradually add the numbers in the list to it until they're all there, until the accumulator represents their sum. Okay, and you can see that happening in the second clause on lines 11 and 12. So on line 11, you'll see we're pulling the first element, the head, off of the list, and the remainder of the list is going to be the tail again. And the accumulator is also the second parameter here. And then we're going to recursively call sum and pass it the tail for our new list and add the head to the accumulator. So if the accumulator started out at 0 and the first item on the list was a 3, at this point 3 would be getting passed to sum as the accumulator parameter. So those are our options. We can do accumulators like we do in sum. We can do the same sorts of things, adding, prepending without an accumulator like we did in keep odds. I've shown you both ways. Either of these functions can work either way. We could do an accumulator with keep odds, and we could do sum without an accumulator. You just pick the one that makes the most sense, that makes the cleanest code as you're writing it. That's the rule. There's no other rule. It's just whatever is going to make the cleanest code. And that's going to come down to you and just having some experience.